Hi students, my name is Sumalata. In today's class I am going to discuss about erythro and threo isomers from stereochemistry. Before watching this video, a small request from my side. If you are not subscribed, subscribe this channel and just try to watch a complete video, then only you can able to get complete information what I am saying now. And another one is, if it is useful and if it is informative, then you can just forward these videos to other students and mention your words in comment section. Now going to topic. Seen erythro and threo. How can we distinguish the particular isomer is a erythro isomer or a particular isomer is a threo isomer? Actually, these erythro and threo isomers are particularly applicable for constitutionally unsymmetrical isomers. Once see here, constitutionally unsymmetrical molecules can only show erythro and threo isomerism. Okay, see, what are the constitutionally unsymmetrical isomers? And before going to this, just try to know about what are the constitutionally symmetrical isomers. Constitutionally symmetrical. Yes, see here this one is applicable for only for unsymmetrical, constitutionally unsymmetrical isomers, but not for constitutionally symmetrical isomers. Why it is? See, particularly the isomer which have two chiral centers or two stereo centers. It need to possess two stereo centers, then only we can able to decide is it having is it belongs to erythro isomer or it belongs to threo isomer. Okay, see here, this is A and this one also A, students. This is B and this one C. This one is B and this one is C. See, if you take this type of arrangement in a molecule or an isomer, that will shows plane of symmetry. Okay, plane of symmetry. See here in this molecule two stereo centers are there, but these two stereo centers are having similar substituents. The substituents which are present at first chiral center or stereo center, those substituents are going to be repeated in second chiral center also. There is no any change. See once, this is A, B, C for the first chiral center. In the same way, this chiral center also having A, B, C, same arrangement and same connectivity also, same side. The groups, B groups are same side and C groups are same side, and A comes in vertical line. See, for this type of arrangement, we can't able to assign is this a erythro isomer or is this a threo isomer. Okay, in the same way, suppose you can see here, students, this is A, B, this one is also A, B, C, B. Here there is no plane of symmetry in this molecule, students, but see here it is applicable for only we can able to decide it is an active compound. For this one is meso compound. To this, if these two isomers are constitutionally symmetrical isomers, that means same arrangement, same groups are present at both stereo centers or chiral centers, students. So that Here we can able to assign, is this compound is a meso, or is this a, having, I mean, is it a active compound or meso compound? Active compound is nothing but, students, there we can able to assign, is it D or L configuration, small d and small l, not capital D and capital L. Small d, dextro-rotatory and levo-rotatory. Simultaneously we can able to assign capital D and capital L, but how can we tell is it meso or is it active? I mean, the active molecules are showing small d and small l configurations, but this meso compound does not showing small d and small l configurations. See here, coming to unconstitutionally unsymmetrical isomers. See, this one also having the isomers which are having two stereo centers. At these two stereo centers, at least one substituent should maybe vary from first carbon, I mean first stereo center and second stereo center. Once see here, students, this one is A and this one is also A. Here B, C, here C and there D, students. See, only see A, B, C for the first chiral center or stereo center, and in the coming to second stereo center, A, C, D are there, not B is going to be repeated here. That means one at least one different group should be need to be there, then only you can able to assign, is it erythro isomer or is it or it comes under as a threo isomer. Now coming to how can you assign erythro and threo for constitutionally unsymmetrical isomers. Just see here, students, this is A and this is also A. These are the two chiral centers. See, this one is B, this one is C, and this one is D, this one also C, students. See, at chiral centers, I mean at these two chiral centers or stereo centers, the similar groups which are present same side to the chiral center, that one is erythro isomer. And if the similar groups which are present opposite inside, then that will comes under as a threo isomer, students. See, same A and A, B, C, here C and D. See here, students, see, these two, these two groups are present opposite side to these two stereo centers or chiral centers, then it will comes under as a threo isomer. If those are in same side, that one is a erythro isomer. If those are in a opposite side, that will comes under as a threo isomer. Now we can go to discuss about some examples. See here, students, CH3, HCl, HCl. Just check it once. Is it possible to assign erythro and threo isomer, nomenclature for this type of molecule? And one more isomer you can take here, CH3, and this one also CH3. Here hydrogen chlorine, and here Cl and hydrogen C. These two for this type of molecules we can't able to assign erythro and threo nomenclature. Why? Because see, it is having plane of symmetry and it's a meso compound. It doesn't have plane of symmetry, but it's all it will comes under as a, is it dextro-rotatory or levo-rotatory? This is a active compound. Why? Because D and L, small d and small will be possible, that is the meso compound. Why it is not possible? See here, these two are the constitutionally symmetrical isomers. Why? Because The stereo centers which are present in this type of isomers are having similar functional groups. For the first stereo center and for the second stereo center, those are the similar functional groups repeated for these two stereo centers. Okay, so that we can't able to assign erythro and threo for this type of compounds. Coming to next example. See, CHO, CH2OH, it's an aldose, students. HOH, HOH, and CHO. See, this one is HOH. See, this one hydrogen, OH, and another mirror image to this one, students, HOH, HO, HCH2OH. Now you can try to assign which one having erythro form and which one comes under as a threo form. Once see here, students, the see here that these two are the chiral centers or stereo centers. See here the differentiating function, this one is aldehyde group and this one is alcoholic group. Okay, so these are the these type of molecules comes under as a constitutionally unsymmetrical molecules. See, the functional groups, similar functional groups present same side. Okay, so that it's a which conformation? It's an erythro conformation. So it is a erythros. It's an erythros. And you have to write another thing also here. See, at bottommost asymmetric center, the OH group present which side to you? That is present right side to you. So you can write this one also, Erythros. Okay, coming to mirror image to this one. See, this is one stereo center and this is another stereo center, students. Here the OH groups are differentiating functional groups present left side, this side. Okay, this one also erythros. Why? Because they are also present at same side and here also present same side, so that this one also comes under as a erythros. Here the OH are functional group present left side to you, so that you can write L erythros. Okay, coming to this one, here this one is a stereo center, this is another stereo center, this is one stereo center, this is another stereo center. These two are the mirror images. See here, students, the differentiating groups are similar groups, differentiating functional groups are similar functional groups present opposite side, so that it's a threos. So here see, OH is right side to you, so that you can write D threo, students. Is that clear? Coming to this isomer, see here also OH groups are hydrogens. You can consider any one of these two. This is also a threos. Here OH is present left side to you, so that it's a L threos. Student. See here, you can assign R and S configuration for this one. This is 1, 2, 3. So that it's a anti-clockwise direction. You can directly write R. Why? Because list is on a horizontal plane. And another one is, this is 1, 2, 3. This is also anti-clockwise direction. So you can directly write this is also R configuration. And coming to this isomer, this is the mirror image to that one. You can directly write this is S configuration and this one also S configuration. Coming to this one, see here, students, you have to assign here configuration. This is 1, 2, 3. It is in clockwise direction. You can write yes, because list is on horizontal. And for here also 1, 2, 3. 1, 2, 3 anti-clockwise direction, so that it becomes R because of least one. And for this one, this is the mirror image to that one, so that you can directly write this is R configuration and this one is S configuration. See students, by seeing this erythro and threo isomers, you can identify which one are the diastereomers and which one are the enantiomers. See, these two are the enantiomers. Just say I am going to give numbering 1, 2, this one is 3, this one is the 4 students. See, these two are the enantiomers and these two also enantiomers. 4 and 3 are the enantiomers, 1 and 2 are the enantiomers. Coming to which one comes under as diastereomers? See, 3 and 2 are 2 and 3 are the diastereomers. 2 and 3 comma, and 4 and see, this is R and S, this is S, R, R. You can write 4 and 1 R. Anyone, you see, this 4 is diastereomer to second one, and also this 4 is diastereomer to first one, because what is the diastereomer's definition? For diastereomers which are optically active and the configuration is similar for some centers and opposite for some centers. If you can observe, see, this is the fourth one, L threos is diastereomer to the L erythros. In the same way, this is diastereomer to the L threos, is diastereomer to the D erythros also. Okay, see, why here 4 conformations are possible? Why? Because we already know 2 power n is the formula to identify or assign how many isomers are possible for that particular isomer. Is that clear here? N is the number of stereo centers or number of chiral centers. Here for this molecule, 2 stereo centers are there, 2 power 2. 4 isomers you have see here. Among those 4, see, these 2 are the enantiomers and these 2 are the enantiomers, and 4, 2, next 3 and 1, these are the diastereomers. See, diastereomers. In the same way, you can take some more examples, students. See, one more example, COOH, CH3, HOH, HBr. This is one isomer, students, and mirror image to this one you can take COOH, CH3, here OH, that side hydrogen, this side bromine, and that side hydrogen. This is the mirror image to that isomer, and see, COOH, CH3, HOH, HBr. Okay, coming to one more, mirror image to this one, CH3, HOH, BR, H. See here, students, the differentiating one is hydrogens. Two hydrogens are present in same side, and here 2 hydrogens are present in opposite side. These 2 are the mirror images. See, this molecule having 2 stereo centers. See, to this one, 2 hydrogens are present in same side. You can directly write it's a erythros. Is that clear? Which erythros? See, bromine, differentiating functional group is here, right side. So, this is D-erythros. Or erythro you can write. It's not an aldose, so that you need not to write erythros. Just you have to write erythro only. Is that clear? Coming to here, this one also erythro form. See which erythro, the functional group is left side to you, so that this is L erythro. Here this is threo, because OH groups are opposite to these two chiral centers. This is D threo, this one L threo, students. These two are the enantiomers and those two are the enantiomers, and this one and that one diastereomer, and this one and that one diastereomers. I hope you understand about this one. Thanks for watching, students. If you feel this is useful and informative, please don't forget to forward, and don't forget to subscribe, and don't forget to like, and just mention your words in comment section. Then only I can able to make more and more videos regarding chemistry. Thank you, students. We will see in the next class. Bye everyone.